Hello YouTube, today we're going to be talking about shifts in supply and demand. So I'm just going to give about 6 examples, they'll be quick though, about how a certain situation might shift the supply and demand of a certain product or good. So let's get into it. So, use a supply and demand diagram to illustrate the effect pretty much on the market for oranges, assume it's currently at equilibrium, and determine whether the equilibrium price is higher or lower or indeterminate depending on the original equilibrium. And then explain your answer. Okay, so first one, there's a massive freeze across the state of Florida. Okay, so we're Orange Company, and there's a massive freeze. So what's going to happen? Well, if there's a massive freeze, that means there's going to be a huge shift in supply because there won't be enough oranges around. So that means it'll shift the supply to the left. That means it's decreasing supply here. So that means our new curve would look a little something like this, and we'll call this S2. If I could fit it in there. 2. Cool. Alright, so what happens then? Well, that means our equilibrium point will shift to here. So, the equilibrium price, the original one, was down here, and now it's above. So our equilibrium price is shifted above, so Q is above the original one, so it increased. It's higher. But what happens to the quantity? Well, the quantity demanded actually decreases. Notice how our demand was here. Quantity demanded was there. That's a Q. And now it's shifted over here. So we lost, there was a decrease in the quantity demanded. So I'll just put Q decreased. So you can explain your answers obviously in words, but to make for the effective time, we're just going to kind of go on through that. Okay, so now the pesticides increases the yield of oranges of every tree. So, what happens when a new pesticide, well, it even tells you, increases the yield of oranges. So that means what? Your supply is going to increase, and that is a shift to the right. Think of right and left as increase and decrease, right meaning increase, left meaning decrease. So we're shifting our supply in that direction. We'll call this S2. So what happens? Well, over time, the new equilibrium point would be here, where supply equals demand. And where is that relative to the original equilibrium point? Well, it's below it, right? So our equilibrium point is lower than the original. But what happens to the quantity demanded? That actually increases. Why? Because we originally were at here, say it's Q star, and now we're at the new Q, we'll call it Q2, and demand increased to the right. So there's more quantity. So pretend like this was 0 and this was 100. You went from, say, 50 to 65. Kind of an example. So if you want to think of numbers, think of it like that. But that pretty much answers that question there. Okay, the FDA reports that vitamin C is beneficial than previously thought. Okay, so let's think about this now. If I told you that if you had more orange juice, if you go get more orange juice, that you'll be a lot healthier in life or something. Some study like that, the more orange juice you drink, the more it correlates to the prolonging of your life. Remember, correlation doesn't mean causation. Anyway, just that kind of thing. You'd want to go out and buy more orange juice. Say, hey, I want to get healthier or whatever. So our demand of the general population will shift to the right, and this will be our D2. And shifting to the right is an increase. Just to show that there. So our new point that would be established, our new equilibrium point would be here. So what happens? Our equilibrium point is above the original, but what happens to our quantity? Well, our quantity is also higher too. If you notice, we had Q star would be our original equilibrium point, and P star was the original price. The price went up, and the quantity demanded went up when the demand increased. So that means more people are willing to buy it at a higher price, knowing the news that it benefits your health. Okay, so cranberry shortage drives up the price of cranberry juice. Okay, so if we have a shortage, wait a minute, this is the cranberries. We're talking about oranges. Remember, this is the orange market. So assuming cranberries and oranges are substitutes, then what would happen? Well, if there's a shortage of cranberry juice, then that means the demand for orange juice would increase. Because if there's not enough cranberry juice, people are going to buy more orange juice as a substitute. Think of it like that. So that's an increase or shift to the right. Our new equilibrium point would be up here, so it's kind of the same as the last one. But the key thing to note here, I'm just going to, for bullet points, it's like substitutes. I can't spell. I'm just going to, okay. So, substitutes and would cause that shift to the right. So our equilibrium price, again, same thing, be higher because it's higher. There. And our quantity would also be higher as well. If you notice from before the difference here. It's pretty much the same situation as this example, but just a different condition. Okay, so 1 and 3 both occur simultaneously. Well, what was 1? 1 was massive freeze caused a leftward shift in demand, so let's do that first. So there was a leftward shift in demand, or supply, excuse me. So our supply moved this way, so S2. And what happened in, what was the other one, 3? FDA says more vitamin C, so rightward shift in demand. So we have a rightward shift in demand. Rightward, yeah, oops. Rightward, there. Okay, so what does that mean? Well, there's a lot of conditions that could happen here. Depending on how far we shifted right in demand and how far we shifted left in supply, you could have many things happen. You could have an equilibrium point here. You could have an equilibrium point here. You could have an equilibrium point here. Depending on which conditions happen at which certain point in time. So, but one thing is consistent. Everything is above, all the equilibrium points are higher than they were originally. So that's the key to note here. So equilibrium point is higher than it was before. But what about the quantity? So Q star is the original equilibrium point. And we could have a Q here. We could have a Q here. Or we can even have a Q relatively close to the original Q star. So you cannot determine the quantity that is demanded. So this one you would just say indeterminate, but for the shorthand I'm going to do not applicable. So that's kind of how you see it there. Let's try this next one. 2 and 4 occur simultaneously. Okay, 2 was new pesticide increases the yield of orange. That was a rightward shift in supply. So let's draw that real quick. Rightward shift. And 4 was cranberry juice shortage. Was a rightward shift in demand. Boom. D2. Okay, so what happened? Well, you could have an equilibrium point here, here, and here. Now, if you remember kind of how I explained it last time, well, look, there are points both above and below the equilibrium point, that from the original equilibrium point. So our new equilibrium point would be indeterminate, or in this case, and for shorthand, I'm going to say not applicable. You don't know if it's going to be up here, down here, or over there, or wherever. You cannot determine that equilibrium point. However, the quantity, if you notice, this was Q star. The quantities has increased to the right. There is more quantity demanded, so that means we have an increase in quantity because all the points are to the right of the equilibrium point. Or, yeah, right of Q star, I should say. Okay, so hope that helped with supply and demand shifters and how there's both a shift in demand and a shift in supply. And, you know, just kind of keep practicing and making up situations on how it would affect the supply of or demand of a market. It's a pretty fun exercise, just kind of think about it, but I would always recommend to draw a picture to help you with this process.